You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
Hi, this is Mike Balzer, and Chris couldn't make it today, but we've got a special guest, and I hope I'm pronouncing this correct. Is it Ramani?
Ramani is right, yes.
Okay, and he is the CEO of a company called VisiSonics. Is that correct?
Actually, I'm president and founder. There's someone else who has the CEO role.
Okay.
I used to be CEO, but...
but it is VisiSonics, correct?
That is correct.
And the reason I have you on is because you have put out a brand new, well, not necessarily product, but a line of audio, what would you call it, immersion type processes that was just picked up recently by Oculus. Is that correct?
That is correct. One of our products was picked up by Oculus, and it's going to be incorporated in the SDK.
Okay, so let's get right into the questions. So who are you, and what do you do for a living, and where do you reside?
Yes, so we are a University of Maryland spin-out. My day job is as a professor of computer science at the university, and we've been developing technology around 3D audio for the past decade or so at the university. And we were doing VR and 3D audio before it was fashionable. We've been focused on getting audio capture for 3D, so we do microphones, and we also do the process of rendering 3D audio so that when people listen to sound over headphones, we can place it with pinpoint accuracy. And I'm glad you have our website up there.
Mm-hmm.
And so about 3 years ago, we decided to spin it out. We had all these wonderful technology sitting at the university. We spun it out, and we started VisiSonics. It's been an interesting ride. We are an East Coast company, so I guess our evolution is a little bit different from the people on the West Coast, but we were more focused on sort of bootstrapping and building our technology out. We've developed this hardware product that you see on the left of your screen, and we also continue to develop this engine, which is on the right of your screen. And we develop both products. The camera you see on the left is already selling, and we'll talk about it in your later as I see from your questions. And
Yes,
and as far as the right-hand side stuff is concerned, there's an audio engine, which we'll talk more about as we go along.
Oh, great. Yeah, I'm really excited to know more about it. I brought in a composer who's done a lot of music, and I kind of brought up, or actually had him on to kind of talk about how a composer and arranger would start using VR. And we didn't get really technical, so I'm glad that one of your employees reached out to me because I really want to know more about this. And I've studied it as well, so I'll kind of get directly into it. So how long have you been in business as VisiSonics?
We sort of registered the company a few years ago, but we've been in business about 3 years.
3 years, okay. Yeah. So what is different about 3D audio, or at least your particular version of it, and what do they call it, multi-positional sound that you've had in games for years now? What is the difference?
So the main difference is when you hear sound in the natural world with your own ears, and when you're in an environment, it's naturally 3D. You hear the sound with pinpoint accuracy. Even if you close your eyes, you know where that sound's coming from, and you know what environment you're hearing the sound. Most movie audio, most gaming audio tends to be not as immersive as the real world is. You have a bunch of speakers that play sounds. You can get a position as far as left and right is concerned, and even you might be, with a multi-speaker system, able to pan along the azimuth, but you do not get up or down. You don't get near or far. You don't get below you, behind you, and all that good stuff. And you don't get pinpoint accuracy. And when we say 3D, it's as if you're listening to the world with your own ears without those speakers out there.
Yeah, and obviously, and we'll get to those questions a little bit later, I mean, that just opens up a wide possibility. But in doing so, if I understand correctly, this is still done with two speakers or a headset, correct? You don't have those multiple drivers, or in the case of movie theaters where you got speakers all around you. This is done with two speaker or a headphone set, correct?
Absolutely. So the thing is, you hear the world with just 2 ears, and you're able to play sound in 3D. And so if we get the sound coming into your 2 ears right, with those two headset speakers, and we do the job right, we should be able to reproduce that world. And that's what our software does. It reproduces all those cues that you need to sense the world in 3D.
Yeah, that's really interesting, and we're going to talk a little bit. Hopefully, you'll kind of give us a sneak peek in kind of the science behind it. But like I said, I've read a lot about it, so I've got some ideas, and hopefully you can kind of confirm what I'm believing that you're doing. And I think the reason why it really hasn't been available now is because you didn't really have the horsepower to do it in real time. But I'm getting ahead of myself. So let's kind of look at the technology, and I'm going to bring up the web page again. You have this camera that you sell. Actually, it's a camera / audio device. And if I understand correctly, there are 64 mic elements in here. And I'm assuming they're probably cardoid or super cardoid and designed electric mics in order to just, obviously I may be wrong here, but with standard mics, you may have too much bleed over. So I'm thinking they're probably a little bit more focused than a standard omnidirectional. And from what I see here, it looks like there's an on-off button, and it's on a small tripod. But if I'm correct, it's 64 elements. And is there a reason you chose 64 elements, not 128, 32?
Sure. Let me take a step back. So, in fact, we want that bleed through. So those are all omnis. And our software, so essentially that device, you don't have a sense of scale in that one image. So the sphere is about the size of a human head. And so it's about 8 inches across in diameter. And what that does is, that's my co-founder, Adam O'Donovan, you see in that image.
And that's the size of it, correct? Yeah, that's a better comparison.
Better compare. And he's holding it up in front of him. That's an early prototype with that funky blue color that you see. So what this device does is it has 64 microphones, which are omnis, which sort of trap the sound coming from every direction. And then our algorithms do their magic. They decompose that sound into a bunch of plane waves coming from different directions. And then those plane waves, which are coming from different directions, that's a sort of a mathematical term there, can be processed in a couple of ways. One way we process them is to create a visual image, which we can then overlay on the camera image. So, for example, if I were to be photographed with this camera, I mean, if I were to be, live in its, you would see my red spots coming out of my mouth as I spoke live, and these are, and this device is being used by lots of people who want to study the acoustics of space, the acoustics of car cabins, and things like that. And it's been sold into the auto industry. Tesla is a customer, for example. And many folks in that industry want to design a quiet cabin, and they want to know where the noise is leaking in from in real time as they're testing. So that's one side of the business. So that's sort of the analysis of 3D sound. But this device can also be used as a telepresence device. You can place it at some location. It creates a visual panorama as well as an immersive audio output, binaural audio output, and you are as if you are at that location. And
so it does the processing internally as well.
it does the processing on a GPU of a laptop. So you talked about, so there's lots of fancy engineering in that product. All 64 mics and all 5 HD cameras all come out of a single USB 3 pipe. And that single USB 3 pipe goes into a laptop which has a GPU in it. That GPU does the audio decomposition. It does the video stitching, all live and real time, and it pipes out. And we have a few experiences we have shared on the Oculus Share site. People can download. One of our engineers went to the Great Wall of China, and he captured a few scenes there. We have another scene in a bar locally.
Do you have a link on your website for that?
We do, and I'll be happy to send send it to you after we are done with this.
Sounds good. I'll put it in the show notes.
Yeah.
Okay. So, I was going to hold this off to later, but, this seems like a great device, but it's probably pretty expensive, correct? Or, what would it cost to get one?
Yeah, right now it's a special device which is sold directly, as I mentioned, to research labs. So it sells for $65,000, similar to one of the fancy RED cameras, for example, someone making a movie might do. But compared to other pieces of audio analysis equipment, it's much cheaper than those and much more capable, if you will.
Yeah, well, it looks like it is. But let's say for the independent like myself, who just, can't afford a $65,000, but really wants to get into this, are you planning to come out with something less expensive, or maybe a lease or a rental program? So if I only needed it for a weekend shoot, I'll be able to rent one.
Absolutely. We are already renting out. Our rental program is in sort of a beta phase. We are supporting a few people who have contacted us right now through the rental, and we are going to be growing that process.
Okay. Well, that's good. Well, like I said in one of my questions here, I'll jump to it now and go out to the website. One of the things that you seem to be applying this to, and this is the reason that I became aware of it, is obviously the Oculus Rift has gotten a lot of attention for its VR, but one of the things that has been missing, even though it's been visually stunning, audibly or orally, it has not been, let me get that right, orally, it's not been the experience. Like I said, they use multi-positional, but not this 3D perspective. And you do have a demo, I think it may still be out there, that somebody can download if they've got a Rift and actually experience it for themselves using the, what is the demo that normally goes
Tuscany.
Thank you, the Tuscany. And so if you're familiar with that already, if you're a DK1 or DK2, go ahead and download it because it is a unique experience. But it's called RealSpace 3D, and it was in the news a couple of weeks ago that they license your technology, and I guess it's going to become the de facto audio functionality to it. But the other questions I have is that it works with other gaming engines, and you identify the Unity engine. Hasn't Epic also approached you, or are you working out a deal with them with their Unreal engine as well?
So it turns out the Epic world, when people do audio in Epic, the basic audio which is sort of combined with Epic is rather rudimentary. Epic is great as far as the visuals are concerned. So many people use a couple of audio engines from third parties. One's called Wise, and the other one's called FMod. And these folks essentially provide the audio capability that game programmers need for Epic usually. Or some other people have homebrew engines. So what we have are plugins which go into FMod and into Wise, and both of those, the Wise plugin is in beta right now. It's about ready to be released, and the FMod engine is in alpha. It's being played around in-house, but that will also be released. And we both Unity and Epic will be supported. And so you can essentially, in a game, a game developer, all they need to do is choose a sound, tag an object. As it moves around, as its environment changes, all those will be automatically reflected in gameplay, and you'll get the correct sound positioning.
Okay, so as mentioned, Unity already exists. It's coming for the Unreal Engine as plugins for already audio environments.
Yeah.
Is there a cost for this? I think the Unity is free, right?
So because this is a new business and we are still trying to figure out, what these cost models are going to be, and we want widespread adoption. Right now, we are giving away a beta version of our engine, and with those developers who actually want to ship products, we are entering into very developer-friendly licenses on a one-on-one basis after they've sort of played around with it and figured out, this is the product for them. And we support them through that. And this gives them an ability then to get our immersive audio right into their game with our support.
Okay, well, I've got somewhat of a direct question for you. I'm working with a company called Occipital on creating, with their structure sensor, which is a 3D sensing, or what do you want to call it? Well, sensor that allows me to do something very similar to the Microsoft Halo that you've probably been reading about, or Holo, excuse me.
HoloSense.
Correct, but it does something like HoloLens. It does something very similar to that, but it works in the iOS environment. Does your audio engine work in iOS other than the Unity, or is it specifically with the Unity, or do you have something that's a little bit more lower level that I could include, like a framework?
Our engine does compile on iOS, but we haven't built an API for that yet. We've just sort of tested, its efficiency and so on. Right now, iOS support is through Unity.
Okay. How about I do a virtual introduction with you with Jeff Powers from Occipital, and maybe you two can talk to one another, and maybe he can beta test your API. One of the reasons. Yeah, and one of the reasons is that he's working on a lower level, one, because he's a fairly good programmer, but he's using OpenGL and Metal, which obviously gives you better performance, even though Unity and 5 is going to have better performance. So he may want to look at it from that perspective, and it could be an interesting relationship. So I don't know if you're familiar with the structure sensor, but I'll provide a link later on for you as well.
Look forward to it.
So getting back into maybe a little bit more about, well, maybe a general overview of the theory, because you're only using 2 drivers on each ear, obviously from what I've understood in the past, in order to give a true 3D sense, you have to take into consideration amplitude, frequency, and phase, and delay as well. So I'm assuming you're doing all of this in real time. Is that correct?
That's correct. So what, if I may sort of jump into the tech a little bit, lay it out in simple fashion. So what we are trying to do is redo in software the changes that occur to a sound as it leaves a source in the real world in a given environment and comes to your ears. And then let your brain do the magic it does in real life and figure out where that sound is. So those changes which happen to that sound come from 3 sources, and I call them the 3 legs or the 3 pillars of spatial audio. The first leg is your body and your head. So essentially, this is like the Heisenberg uncertainty principle of audio. I'm not using Heisenberg in the in the
Breaking Bad
sense, but so essentially, when you hear sound, your body interacts with the sound waves. So it's as if the sound waves which came from the source never come in pristine fashion to your ears. They're changed by your body. And they're especially changed by your head and your ears. So your ears are, not just for nibbling of your significant other, when you're passionate, but they also have another function. They change the sound that you hear before they enter your ear canal. And these changes are different for sounds which are coming from different directions, different locations. So that's one.
And if I could just interrupt for a moment, this experiment has been done for decades now, where they take a model of the head and ears, put microphones in the canals, and then record from it. But the point is that stationary. As long as you're within that sweet spot, then you hear it as though it were yourself. But what you're saying now is that you take that model and now can apply it in real time. So I'll let you finish.
Yeah, well, I'm very glad you brought that up. There are wonderful recordings of those binaural recordings, as they're called. They're available on YouTube. There's a particularly famous one which has got several million, watches, which is called, I think, the Virtual Barbershop, which is a recording with one of these heads with microphones in the ear. But what we did is figured out the process of that kind of a recording and reduced it to software. So essentially, you can put in a sound you want to play, and we do all the transformations that would have occurred to that sound to get into that binaural recording, but do it entirely in software. And I mentioned one leg of that was your body. The second leg of that piece is the room in which that recording is taking place. So instead of just having a single copy of that sound reach your ears, you get many, many, many copies because there's reverb. So there's sort of, if you're in a shoebox-shaped room, you get 6 reflections from the 6 walls. But now each of those reflections again reflect in all the other walls. So at a second level, you have 36 reflections. And then at that next level, it's 6 cubed, which is 216 reflections. And very soon, you're getting thousands and thousands of copies of that same sound. And all of them are coming from different directions, all bombarding you. And now each of those copies is now interacting with the body from different directions. So this whole process is becoming more and more complicated. And let's sort of finally bring in one more piece, which is not there in those binaural recordings. This is head motion. So when I move my head, everything changes, and my software needs to account for that. And this is extremely important in virtual reality, and we do that. And so essentially, our software engine lets you specify how much of the CPU you're willing to devote, and it does the best approximation and gets you the best sound it can within that CPU budget for getting the binaural sound transformation for that sound.
Yeah, and that's always the key in functions, is because there's discrete quantizations. How many do you want to actually perform? As you said, this could work infinite amount of smaller pieces, so you have to at least put a boundary. What is that boundary? What do you think realistically? And I don't know if you have the horsepower for it now. Like you said, you can allot so much CPU. If I gave it everything, what do you think that level would be? But, realistically, it's just, I'm liking this to the fact is that we have a 44.1 kHz sampling rate with 16 bits, which for most people is more than adequate, other than the people at Pinocchio, I guess, would argue with that. But for the most cases, people see that as a realistic representation. So I'm assuming there are certain limitations as well, or barriers, or the point that you approach to it where it's as realistic in life. Can you shed some light on that?
Yes, excuse me. There are a couple of barriers to complete realism. One is if you want to simulate some real-world effects, such as different wall materials, different absorptivity in different frequency band for wall materials, then you need to do more sophisticated processing, which something like an iPad or iPhone might not have, or a Samsung Gear or whatever. But on the other hand, there's another barrier to complete realism. It's that all of our heads and bodies and ears are slightly different. And because of this, we all have a feature which is called the head-related transfer function, which is a component of our engine, which we use a generic one in our engine. If we wanted to get pinpoint accuracy for everybody, we would need everybody's HRTF. But there is exciting news in store for this. We have technology which allows us to get everybody's head-related transfer function. And that's technology we'll be rolling out later this year. And
interesting.
And that would allow everyone to perceive true 3D much better. And finally, there's all sorts of real-world things. So when we model the room, we might not put in all elements of the furniture and so on in there, because all of this, it's a little bit akin to ray tracing and graphics. If you have more horsepower, you can do much more photorealistic things, and it's somewhat similar to that.
Okay. Well, and to take this into the example I gave earlier, if you had in real time a 3D map of the room, let's say with the structure sensor we talked about, you could probably apply that realistically so that you would be able to get those occlusions and reverberations based upon real objects, which would even add even more realistic simulation of audio. Is that correct?
That's absolutely correct. And those are the kinds of things I think we'll be working to incorporate in our technology in future iterations.
Good. Well, I hope you and Jeff can hit it off. I'd like to see what comes out of that. So on that, this, I guess we're heading down towards the end of this. So currently, if you wanted to use this technology, you have some samples out there on your website. I'll make sure I put them in the show note under demos. Is that correct? Under the RealSpace?
That's correct.
Now, do you, let's see, what do we have? It says headphone. Do you need to have the DK2 or the Oculus Rift?
Or can so you don't really need to have that. Of course, for immersion and head tracking, having the DK2 is useful. But we have demos of a couple of levels using just a gaming engine. So if you have Unity, unfortunately, you do need Unity Pro. You can't do it with Unity Free because Unity doesn't allow external programs to be called from Unity Free. And since our device is a plugin, it's an external program. And I think Oculus was able to convince Unity to let the free version call just their SDK. So they exposed a few of the functions, allowed them to be called from the Oculus plugin for Unity, but not in general. Hopefully someday they will allow that so that a broader group of developers can use it.
Yeah, and specifically that's for developers. Now, if you wanted to create a runtime for an audience, you don't require the Pro engine, right?
You don't need the Pro engine.
Okay, so the demos that you have out there don't require the Pro. It's just if you're a developer, so you can still enjoy the audio experience.
So you don't even need Unity for that. You can just download it and enjoy it. Yes.
Right, because the runtime's built into it. So yeah, and I'll make sure that that's in our show notes. And they are very interesting, and it is different. I mean, if your experience in video gaming is positional, which is more amplitude-based, this is a whole different world, and I do wish people would go out there and experience it for themselves. Which gets to another item. Let's take out the visual point of this. What about, and as I gave him my example there, you created a player, either a plug-in for an iOS or Android device that just allowed you to experience being in a field or near a brook or in the forest. Wouldn't that be kind of a cool idea?
Absolutely. And in fact, one of our developers who's using our engine, we just put out an interview with him on our website. You should check it out. He's into building these immersive experiences which are calming, if you will, and he's and serene. So he's put together, I think it's called Eden River, and he's put together an experience. There's lots of Twitter activity yesterday about it, around that, and we have an interview with him. And absolutely, I think there are all these experiences which are possible. And we are tech geeks, and we need the creative folks with these wonderful ideas to come in and use our technology in ways such as the one you suggest. And we look forward to supporting them when they do that.
Okay. And does he have a demo? Does he have a demo?
He does have a demo, and I can. You can.
Please.
Yeah.
I'll put that in the show notes as well. I personally want to experience that because I'm also the tech geek, but I'm assuming I'm also creative. At least some people say I'm crazy creative. But what I was hoping to do is be able to, my wife is a psychotherapist, to provide something like that with the Oculus Rift. But man, it would be kind of nice to, let's say, have the disembodied voice of your therapist talking over, a forest ambient environment that you're in. Maybe on a couch, who knows, maybe just sitting in a chair. That would be a whole different experience. And she really works hard to create an environment that's very quiet and serene, lighting, artificial LED candles, to give you that very comfort that you're looking for. And I could see this really working out in that area. So I'm glad that somebody is moving in that area. So on that, this is really exciting, and I really appreciate you taking your time to come on and kind of talk of some tech with me, and also to experience. Like I said, I'll have all these links in the show notes, and to our audience there, please take the time to download this. If you've got a Rift already and you haven't, please do. It really adds a different experience, and I'm looking for it as a developer to see what I can do with it. So again, Ramani, I appreciate you coming on and sharing with us this great new technology. I do have one other question. There's a company that's getting a lot of what do we call it, airtime because of their VR experiences for the Google Cardboard, and that's Jaunt. Is that correct? That seems, I looked at their hardware, it looks very similar. Are they using something licensed from you, or do they have their own special brew?
No, they have. We have something similar in the video space, though there are sort of differences. They use many more cameras to create a stereo thing. We only give you a panoramic view. That's on the visual side. Their visual side is all done in post-production. We'd give you a live feed, if you will. But on the other hand, where we shine in comparison with them is audio. They do not really have any sort of audio technology beyond some things called sound field recordings, which are relatively unable to produce that pinpoint precision that we've talked about. And it would be, I think we have something complementary, and that's perhaps a collaboration waiting to happen there.
Oh, excellent. I hope that does happen, because even though, like you said, it had a full sphere type visual, the audio, even though it did track you and then you could shift your head and the amplitude would change, again, like you said, it was like more of a cylinder other than a sphere, at least in my sound presence. So I'm glad to hear that there might be some talks in that area, because the marriage of their obviously visual world with your audio world would really create something. On that note, do you have any concerts that you've recorded? Do you have any clips out there that may also put in the show notes?
We do have this one experience on the Oculus Share, which I mentioned I would send out to you. And so that's other than that, we have some demos in Unity, built-in Unity, but not of real-world things, as you mentioned. The real-world stuff is in that Oculus Share demo.
Okay, well, I'm gonna go out and get it and probably try it today or this weekend. So again, Ramani, I really appreciate you coming on and answering my questions, and I look forward to seeing more in the pipeline, and I'm looking forward to see what you can do with Jeff. So
Okay,
again, thank you.
thank you very much, Mike, and good luck to all things 3D as well.
Thank you very much.
Bye.
Bye.